This is section 2.3, part B. We're continuing our video notes. Looking at example 5, graphing the following equations. I'm going to start by finding 3 solutions each. I'm going to make a little table here, x and y values. I'm going to start by just plugging in some x values. Since my equation already has y solved for, they're the most convenient values to substitute. So we'll start with 0 being the easiest value to plug in, because that gives us negative 3 times 0 plus 4 is 4. Then we'll plug in 1, and so that gives us negative 3 times 1 plus 4. That's negative 3 plus 4 is 1. And maybe negative 2, just to plug in something a little different. Plug in a negative number. So negative 3 times negative 2 plus 4, that's positive 6 plus 4 is 10. So I have negative, we'll start with 0, 4. I don't know, I was on the last one, still in my head for some reason. Start with 0, 4. Graph that point. Then we'll start with 1, 1 next. Then the negative 2, 10. All right, now I'm going to connect those. Just want to make a note, if I was graphing this question on my math lab and the computer, I would start with the same steps. I would find my 3 ordered pairs. When you go into my math lab to do your graphing tool and you grab the line, you're going to use that line and click on your starting point. Then it's going to start automatically following your cursor around and tracing it until you click on your second point. At that point, it automatically connects. It doesn't give you a chance to click on your third point. But what you do instead is you visually verify that your third point is on the line. It helps you make sure you haven't misclicked on one of your points. If it's not, you can re-click on one of your points and just slide it up and down. All right, question below asks, what is the y-intercept of this graph? I can see the y-intercept, the place where I cross the y-axis right there. I can see that that is at the ordered pair 0, 4. I'm going to do something similar. The next one, just graph this. I'm going to start with 3 points. I'm going to plug in some x values. So 0, that's 1/4 times 0 minus 1, negative 1. Now, I'm not crazy about that 1/4 right there, so I don't want to plug in 1 and have 1 times 1/4. Instead, I want to plug in something like 4 because of that denominator. 4 times 1/4 is 1, minus 1 is 0. Then we'll go back and plug in something like negative 4. So 1/4 times negative 4 is negative 1, minus 1 is negative 2. So I'm selecting not just 1 and 2 for the x values, but 4s on purpose because of the denominator 4 right there, so I can get some integer values. So I first graph 0, negative 1, then 1, 2, 3, 4, 0, then 1, 2, 3, 4, 1, 2, negative 2. Okay, now we're going to connect. And just doing my best with my ruler here to get this straight line. The more points I have, the better. 3 is really the minimum. Looks like I kind of accidentally missed that point, so it might be a little high on that side of my bed. So what I'm looking here, though, I'm looking for the y-intercept, and I can see where I cross the y-axis right there, and the ordered pair is 0, negative 1. Now, our conclusion that we want to draw from this is that our y-intercept, it came from that first point where we plugged in 0. Right? So that's one of the reasons that plugging in 0 is so darn nice. It gives us the y-intercept, which is an important point on the graph. Also, it's because of that 0, plugging in 0 gives you the number that you had added on. That number is also right there in your equation. So the y-intercept of the graph, I should make a note up here, is if this is written in the form y equals mx plus b, then the y-intercept of the graph is going to be b, because I'll have plugged in 0 for x, made that 0x, or 0 times m, is 0 plus b is b. So it is 0, b. our caveat down here needs to say that if y is by itself. So if y is solved for. If y is not solved for, you can still find your y-intercept, it would just not be immediately present. So without graphing, I can state the y-intercept from these two graphs because they have their y's solved for. So the y-intercept in this one will be 0, negative 5. Because if you plug in 0 for x, you do get 0 minus 5 is negative 5. So I know the y-intercept is at 5. In the next one, in part B, I don't have a value added on, so it must have 0 added on. So it's going to be 0, 0 for my y-intercept. There's not a b value visible, it's just the invisible value of 0. Second page. Now I'm going to graph the equation, not using a whole bunch of points, but using the slope and the y-intercept. Since I can identify where the y-intercept is from an equation or from a graph, I can plot it first, and then from the y-intercept I can count rise and run to find more points. And I can draw the line through the points I've graphed. So I start with my y-intercept. It's at 0, negative 3 right now. So there's my y-intercept. Remembering that slope is rise over run, I can count up 2 for my rise, and then I can count over 5 for my run. And that gives me my next point right there, up 2 over 5. I would do it again, but run out of space in this direction, so I also can count down 2, back 5, because you know that 2 negatives are the same as a positive. So I can count down 2, back 5 as well, if I wanted to get a third point so that I can connect more easily. So that's the graph that would have the slope 2/5 with y-intercept 0, negative 3. Let's try it again. In the next one, I'm looking for a slope of negative 2 through the ordered pair 0, 4. So I'll plot 0, 4 first. And the slope is negative 2. I still need my slope to be rise over run, so my rise is negative 2, and there's no number in the bottom, so I make it a fraction with a 1 in the bottom. That slope is negative, so instead of rise, it's really fall. So we fall 2 and run 1. Fall 2 and run 1. I can do a whole bunch of these. Fall 2 and run 1. Fall 2 and run 1. The more you have, the easier and faster it's going to be to connect. I can also go the other direction. Instead of having negative 2 over 1, I could have positive 2 over negative 1. 2 negatives makes a positive, 1 negative makes a negative, no matter if it's in the top or in the bottom. So I could go up 2 but backwards 1, and I would still line up with the rest. Lots of points. We should be able to connect these swiftly and draw our line. Okay, so in those two examples, 7a and 7b, we were told what the slope was and we were told what the y-intercept was. In example 8, I'm not told those things. I'm going to make a table, and I'm going to use that table to find information about them. Okay, I actually already know the y-intercept, right? Because I know that when I plug in 0, I'm going to get negative 2. So I do know 0, negative 2 is my first point. I'm going to plug in some other points to get the next point. The denominator is 2, so I'm going to choose 2 for my x value, and it would be negative 2 as well. So this would be 1/2 times 2 minus 2. 1/2 times 2 is 1, minus 2 is negative 1. And 1/2 times negative 2 minus 2. 1/2 times negative 2 is negative 1, minus 2 is negative 3. So let's graph these 3 points. First 0, negative 2, then 2, negative 1, then negative 2, negative 3. Okay. Gotta be a little more careful to line it up the fewer points I have. So hopefully I got that lined up correctly. So if I want to use this graph, what is the slope from the graph? Okay. So from one point to the next, it would be up 1 over 2. So the slope from that graph is rise 1, run 2. The slope is 1/2. The slope of the equation matches the coefficient of x if you have your y solved for. Okay. So the graph of an equation that is in the form y equals mx plus b, m and b in constants, is always a line. That's the shape of this type of graph. It's always a line. It has slope m, the coefficient of x is the slope, and it has y-intercept 0, b. Both of those values, m and b, mean something directly about the way the graph is going to look.